Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0238, indicates a problem with the turbocharger boost sensor circuit, specifically pointing to a high voltage output from the turbocharger boost sensor. This sensor plays a crucial role in monitoring the boost pressure produced by the turbocharger, assisting the powertrain control module, PCM, in adjusting engine performance and efficiency. When the turbocharger boost sensor's output voltage exceeds a specified threshold, the PCM recognizes this as an abnormality and stores DTC P0238 in memory. The issue primarily involves the turbocharger boost sensor itself, the electrical circuit connected to it, or even the PCM, which interprets the data received. The location of the turbocharger boost sensor is generally found near the turbocharger assembly, making it accessible for inspection and testing. Understanding the diagnostic approach for this DTC is essential for ensuring optimal vehicle performance. The DTC P0238 suggests that there is a malfunction within the turbocharger boost sensor, which is designed to generate a voltage signal correlating with the boost pressure in the intake air system. When the sensor's output voltage exceeds the predetermined threshold, typically defined as 4.49 volts by the manufacturer, the PCM identifies this as a fault condition and logs DTC P0238. The turbocharger boost sensor's role is vital. It sends real-time data to the PCM, allowing for precise fuel and air mixture adjustments to optimize engine performance. It is generally positioned close to the turbocharger to measure the pressure accurately. An issue in this circuit can lead to poor engine performance, increased emissions, and possibly activate the check engine light. Understanding the exact function and location of these components is key to effective troubleshooting. There are several potential causes for DTC P0238. First, a faulty turbocharger boost sensor may provide incorrect voltage readings, thereby triggering the DTC. This sensor is susceptible to internal failure, which can lead to high voltage output. Secondly, open circuit issues could affect the wires connecting the turbocharger boost sensor and the PCM, preventing proper signal transmission and creating inaccuracies. Finally, a malfunctioning PCM could be misinterpreting the sensor data, leading to erroneous diagnostics. Each component plays an integral role in the engine's performance, so correctly identifying the root cause is crucial for effective repairs. Diagnostic steps must specifically evaluate these areas to isolate the fault efficiently. When DTC P0238 is present, drivers may notice several symptoms indicating an underlying issue. One of the most immediate indicators is the illumination of the check engine light, an alert from the vehicle's onboard diagnostic system signifying a performance-related problem. Additionally, there may be noticeable drops in engine performance, such as reduced acceleration or overall responsiveness, which can be attributed to improper air and fuel mixture adjustments. Increased exhaust emissions may also occur, reflecting inefficiencies in engine operation and potentially leading to further environmental concerns. These symptoms signal the need for urgent attention, as they not only impair vehicle functionality, but could also lead to more significant issues over time if left unchecked. Understanding these symptoms is essential for timely diagnosis and repair. As the first step in troubleshooting DTC P0238, start by turning the vehicle to the on position without starting the engine. This allows the vehicle's onboard diagnostic system, typically accessed via the Honda Diagnostic System, HDS, to initiate and analyze data. At this stage, monitor the HDS readout for the turbocharger boost pressure sensor's output value. If this value exceeds 4.49 volts, it confirms that the failure condition has been successfully duplicated. This step is critical as it sets the foundation for further diagnostics, helping to determine whether the issue is localized to the turbocharger boost sensor, or if it extends to other components such as the circuit or the PCM. For the second troubleshooting step, begin by disconnecting the turbocharger boost sensor connector, which typically has 3 pins. This separation allows for isolated testing of the sensor and its related wiring. Using a jumper wire, connect terminals number 1 and number 2 of the sensor's connector. With the jumper in place, turn the vehicle back to the on mode, and once again, check the HDS output for the turbocharger boost pressure sensor. The expected reading in this specific diagnostic step is less than 4.49 volts. If the output is indeed normal, it suggests that the turbocharger boost sensor itself is faulty. Conversely, if the reading is still abnormal, it indicates that the issue lies within other components connected to the sensor, necessitating further investigation. Moving on to the third troubleshooting step, this involves inspecting the external circuit connections related to the turbocharger boost sensor. To start, ensure that both the turbocharger boost sensor connector and the PCM connector B101P are disconnected. This allows for a safer and more effective inspection process. Carefully examine the wiring for any open circuits or damage that may impede electrical flow. The next part of this inspection requires performing resistance tests on both P3 and SG2 circuits. Measuring the resistance should yield less than 1 ohm. This is the normal condition that indicates no interruption in the circuit. If these standards are not met, it confirms the presence of an open circuit, and immediate attention should be directed to repairing the underlying wiring issues. Finally, if earlier steps have established that both the turbocharger boost sensor and the related external circuit are functioning correctly, examine the powertrain control module, PCM, itself. This inspection step is crucial as it determines whether the PCM has faced any internal issues. If no faults were detected in the previous tests and the readings from the sensors are correct, then it is reasonable to conclude that the PCM may be the cause of the anomalies. Reassessing the PCM may unveil further hidden faults that were not addressed in other inspections. A malfunctioning PCM can lead to repeated DTCs, significantly affecting vehicle performance. Ultimately, if this step confirms a PCM-related malfunction, appropriate actions should be taken to either reprogram or replace the PCM as necessary. After completing all troubleshooting steps for DTC P0238, the next crucial phase is final repair verification. Begin this process by clearing all diagnostic trouble codes stored in the vehicle's memory. This can be accomplished using the Honda Diagnostic System, HDS, ensuring that any previous fault codes no longer affect monitoring. Subsequently, conduct a test drive to evaluate the vehicle's performance under normal operating conditions. During the drive, pay close attention to any warning lights and engine behavior, looking specifically for signs that the fault has been resolved. After the test drive, recheck the HDS to ensure that no new DTCs have been logged and that the previously identified issues are indeed corrected. Confirming that the engine runs smoothly and efficiently post-repair validates the effectiveness of the troubleshooting and repair efforts. To proactively prevent DTC P0238 in the future, implementing a regular maintenance schedule is essential. This includes routine inspections of the turbocharger boost sensor to ensure it is functioning within specified parameters. Regularly checking the wiring connections associated with the sensor is also crucial. Looking for signs of wear, damage, or corrosion can help avoid costly repairs down the line. Furthermore, keeping the powertrain control module, PCM, software updated can prevent potential misinterpretations in sensor data. ensuring optimal engine performance. Establishing these preventive measures can significantly reduce the likelihood of experiencing this DTC again, thereby enhancing the vehicle's efficiency and longevity. In conclusion, DTC P0238 is an important diagnostic code that signifies issues with the turbocharger boost sensor circuit. Understanding the turbocharger's function is crucial, as it directly impacts engine performance and efficiency. Identifying potential causes, such as a faulty sensor, open circuits, or PCM malfunctions, lays the groundwork for effective troubleshooting. Following structured diagnostic steps, including sensor checks and PCM evaluations, enables technicians to accurately identify and rectify faults. Furthermore, implementing preventive maintenance strategies can mitigate risks of similar issues arising in the future. By maintaining vigilance over these factors, vehicle performance can be optimized, ensuring that drivers enjoy a smooth and reliable driving experience. Please like and subscribe to the channel. See you next time!